Assalamualaikum and hi, welcome to lesson 4 of tutorial 4 matrices and systems of linear equations. So let's proceed with our question. So question number 8, given that P and Q, if PQ equals to KI, where K is a constant and I is a 3 by 3 identity matrix, find the value of K. Okay, so let's start with PQ equals to KI. How do we find K? Firstly, you have to multiply P and Q. So this can be done by using your calculator. So I'm not going to show how to multiply. So write back P and Q and then use your calculator. So you will get 16 0 0 0 16 0 0 0 16. Now it's obvious that you see 16 all at the diagonal part, which then you can factor out the 16, which then give you an identity matrix. So do you know what K equals to? So if you see PQ is equals to 16I, therefore your K is 16. Okay, done part A. So how about part B, P inverse? So to find P inverse, actually we can use the equation that you have previously solved. PQ equals to 16I. So I am going to multiply P inverse on both sides. So then we will have P inverse PQ and 16 times P inverse I. So make sure that you put at the same side. For example, if you put P inverse on the left side of a matrix, and then P inverse here should be on the left side of a matrix also. Okay, so make sure the order is correct. So P inverse times P will give you an identity matrix. So identity matrix times Q equals to 16 times P inverse times identity matrix will give you back P inverse. Identity matrix times with Q will give you Q back. So any matrix multiply with identity will give you the matrix backs. So Q equals to 16 times P inverse. So you rearrange the equation. P inverse is 1 over 16 times Q. So are we done? Just that P inverse equals to 1 over 16Q. So this is not the final answer. The final answer is when you solve the P inverse. So 1 over 16 times with matrix Q, 5, negative 6, 15, negative 7, then negative 21, 1, 2, negative 5. And this is not final yet. You have to multiply 1 over 16 with each element. So 5 over 16, negative 3 over 8, 15 per 16, negative 7 per 16, 5 per 8, negative 21 per 16, 1 per 16, 1 per 8, negative 5 per 16. So this is your final answer. Okay? Okay, so continue with question 10. Show that A is a zero of polynomial. You have learned about polynomial in chapter 6. Oh, not yet. We are going to learn about polynomial in chapter 6. So what does zero of polynomial means? When you substitute the value into that function, you will get 0. Okay? So what we should do first is substitute A into that function. So FA equals to A squared. So A squared is 2, negative 5, negative 1, 3, times with the same function 2, negative 5, negative 1, 3, minus 5 times a plus I. And I is actually identity, so we can write that as 1, 0, 0, 1. Okay, so we are going to do this one by one. First multiply. Multiply this will give you 9, negative 25, negative 5, 14. Okay, minus, multiply 5 inside. So 10, negative 25, negative 5, and 15, plus identity. What do you get? So if I calculate all of this, 9 minus 10 plus 1 is 0. Negative 5 minus negative 5 plus 0 is also 0. And same goes for the other two elements, 0 and 0. So from here, you can say that A is a 0 of polynomial. So shown. So I'm going to write in bracket, shown. Okay, so for the next question, hence, find the matrix A inverse and A cube. So the word hence means there's a relation with the previous question. Okay, so previously you have shown that A is a 0 of polynomial. So we are going to use that equation. So write the equation. Write the equation FE equals to A square minus 5A plus I, and this equation is equals to 0. So how do we find A inverse using this equation? So I'm going to multiply A inverse with each element. So make sure you write at the right order. So A inverse times A square minus 5 times A inverse times A plus A inverse times I. So if you see, I write A inverse at the same order. Right? So what happens when A inverse times A squared? It is actually A inverse times A times A. This will give you identity times A minus 5 times identity plus A inverse. Okay, so whenever identity matrix times with a matrix, it will give you the matrix back. Okay, so this I am going to highlight that A inverse times A is equals to identity. And A inverse times identity equals to A inverse, nothing changed when identity times with matrix. So then, this is A minus 5 identity plus A inverse. Now if you see a scalar times an identity, it is still the same. Okay, you cannot simply just remove the identity there because 5i is still 5i. Okay, so rearrange the equation. F A inverse is 5i minus A. So solve the equation. 5i is 5005 and then minus with A 2, negative 5, negative 1, 3. So then the answer is 3, 5, 1, 2. Okay, next is find A cube. So to find A cube, you are going to use the same equation. A square minus 5a plus I equals 0. If you want to find a cube, it is a times a squared. So each term I will multiply with a. So a times a squared minus 5a times a plus ai equals 0. Actually, this is a times 0. And that's why you have 0. Because any matrix times 0 will give you 0. So a times a square is a cube minus 5 times a square plus a equal 0. So what we want is the a cube. So rearrange the equation. A cube equals to 5a square minus a. So substitute the value of a squared. So how do we find a squared? Actually, a squared can be found from this equation. So from this equation, a squared is equals to 5a minus I. So I am going to substitute a squared into 5 times 5a minus I minus a. Then solve the equation. So 5a minus I is 5 times matrix A, 2, negative 5, negative 1, 3, minus identity. And then minus with matrix A. Sorry, just run out of space there. Okay, so solve the inside bracket. So the inside bracket is 9, negative 25, negative 5, 14, minus A, so your answer should be 43, negative 120, negative 24, and 67. Okay, so that's all for question 10. So your task is to do question 9, 11, and 12. Good luck!